Hello and welcome to the MAML Manual. I'm Sebastien.
And I'm Iris.
And today we'll be covering 9 problems from Meet number 4, topic number 3, linear coordinate geometry. Without further ado, let's jump right into it. Alright, here's the first problem of the video. Now, I chose this problem specifically because it talks about standard form of a line, which is going to be super important to understand in this section. Normally, we have slope-intercept form or even point-slope form, and those are important too, but standard form is another way to express a line that we need to talk about. So, as it says, ax plus by equals c, where a, b, and c are relatively prime integers and a is greater than 0. So, for example, 2x plus 5y equals 21 would be valid because 2 is positive and 2, 5, and 21 are relatively prime. However, if I were to do something like 4x plus 8y is equal to 10, well, that would not be in standard form because we can pull out a common factor of 2 and we could express this as 2x plus 4y is equal to 5, and that would be in standard form. And of course, if this were instead negative and negative, this would not be in standard form anymore, and we would have to change the signs of every term. So instead of saying negative 2x plus 4y equals 5, we would say 2x minus 4y is equal to negative 5. I wanted to cover that because even though in this problem they define standard form for you, they don't always do that. So it's important to know it off the top of your head. Alright, let's get into solving the problem now. So the question asks us to find the equation of the line in standard form passing through the point negative 2, 5 and parallel to the line 3y plus 2x equals 5. So to be parallel to that line, we're actually going to need the same coefficients for x and y. So in standard form, as I had written here before, ax plus by equals c. The slope is defined by these two coefficients. We would say slope is equal to negative a over b. And for two lines to be parallel, they need to have the same slope, so therefore a and b must be the same. So we know that in our new line, we also must have 3y plus 2x, and I'll rearrange that order because we should have the x term first. So it should look like 2x plus 3y, and we're solving for the constant. We don't know what the constant is yet. And for that, we take a look at the point. So it says our line passes through negative 2, 5. Well, in order to solve for our constant, we need to plug in the point negative 2, 5 into this equation. So if we do that, 2 times negative 2 plus 3 times 5 would end up being negative 4 plus 15, which equals 11. So our constant is going to be 11. So the final answer to this problem is that 2x plus 3y is equal to 11. So that was standard form for you. It will certainly show up in later problems in this video. Some key takeaways are that if two lines are parallel, then their coefficients need to be the same in standard form. And in order to solve for that constant, all we need to do is plug in the point once we know the coefficients. Alright, let's move on to the next problem. Alright, so another common problem that MAML will have you do is to find the intercepts of a line, whether that be the y-intercept or the x-intercept. Now, I believe it is acceptable to report just the number itself. So, for example, if the y-intercept were 0, 3, you could just report 3. Or, of course, it's always acceptable to report the entire point 0, 3. I would recommend doing that. I would recommend reporting the full point. But if you just report the value, you should be fine as well. But in this problem, it explicitly tells you to report it in x, y form, so that's what we're going to do. So it tells us, find the y-intercept in x, y form of the line passing through negative 3, 6 and 5, 10. So what I'm going to do first is find the slope between those 2 points. So slope is just defined as y2 minus y1 over x2 minus x1. So that would end up being 10 minus 6 over 5 minus negative 3, which is equal to 4 over 8, which is equal to 1/2. So we know the slope of this line is 1/2. So if we were to write this in slope-intercept form, which we should do because we're solving for the y-intercept and we have the slope, so it makes sense to put it in slope-intercept form. So we say y is equal to 1/2 x plus b. We don't know what b is yet, that's what we're solving for. In order to solve for it, let's plug in one of our points. Let's plug in the point 5, 10. So I'll say that the y value, which is 10, is equal to 1/2 of the x value, which is 5, plus b, which is the y-intercept. If we do that out, 10 equals 5/2 plus b, and subtract 5/2 from both sides, and you get that 15 over 2 is equal to b. So our equation of the line is y equals 1/2 x plus 15 over 2. Now we're solving for the y-intercept. The y-intercept is defined as when the line crosses the y-axis. In other words, when x is 0. So, of course, when we plug in 0 to this, we get 15/2 as an output, because this is our y-intercept here. So the point that we would report is 0, which is the x value, and 15 over 2, which is the y value. So our final answer to this problem is 0, 15 over 2. Alright, let's move on to the last three-pointer of this video. Alright, in this problem, I'll introduce you to the concept of perpendicular bisectors. Okay, so if 6, 9 and 10, 3 are the coordinates of two opposite vertices of a square, what is the equation of the line that contains the other diagonal? State your answer in the form y equals mx plus b. So given that these coordinates are opposite vertices in a square, if we draw a line segment connecting them, that would be one of the diagonals of the square. Now the problem is telling us to find the equation of the other diagonal. An important fact about squares is that their diagonals are perpendicular bisectors. That means they form 90-degree angles, which is the perpendicular part, and they bisect one another, meaning that they go through the center or the midpoint. So essentially what this question is asking is to find the perpendicular bisector of the line segment that connects those 2 points. Now, in order to find a perpendicular bisector, you need the slope, which you will take the opposite reciprocal of to find the perpendicular slope, and then you also need the midpoint. So let's work on the slope first. Again, slope is just change in y over change in x, which equals 3 minus 9 over 10 minus 6, which is equal to negative 6 over 4, which is equal to negative 3 over 2. Now that's the slope between those 2 points, but we want the perpendicular slope, which is the opposite reciprocal. So reciprocal we flip, and then opposite we change signs. So negative 3 over 2 goes to 2 over 3. So the slope of the other diagonal is going to be 2/3. We also know the perpendicular bisector will run through the midpoint of those 2 points. And to find the midpoint, all we need to do is take the average of the x values and the average of the y values. So 6 and 10, their average is 8, so the midpoint is going to have an x coordinate of 8. 9 and 3, their average is 6, so the y coordinate would be 6. So we know that our point runs through 8, 6 and has a slope of 2/3. So let's solve. We want it in the form y equals mx plus b. So it's going to be y is equal to 2/3 x plus b. We don't know what b is yet, so let's solve using our knowledge that this point runs through the line. So we would say that 6 equals 2/3 times 8 plus b. So we would say that 18/3 is equal to 16/3 plus b. And therefore b is equal to 2/3. Just coincidentally, that also is the value of the slope. So our final answer would be that y is equal to 2/3 x plus 2/3. And that is our final answer. Now the important takeaway of that problem is how to find the equation of the perpendicular bisector, because that's something that shows up often in this topic. The perpendicular bisector, you have to find the opposite reciprocal slope, and you have to find the midpoint. Alright, let's move on to our first 4-pointer of the video. And would you look at that? We have another perpendicular bisector problem. Instead of giving us actual coordinates, they give us coordinates with letters, meaning that the perpendicular bisector will change depending on what the values of a and b are. Find the equation in standard form in terms of a and b for the line which is the perpendicular bisector of the line segment joining 2a, 0 and 0, 2b. Now, don't be confused by those letters. We're still trying to find the perpendicular bisector, meaning that we have to find the opposite reciprocal slope and the midpoint. Starting with the slope, we know that slope is change in y over change in x. The change in y would be positive 2b. The change in x would be negative 2a, meaning that the slope is negative b over a between those 2 points. Now, we are looking for the opposite reciprocal slope, so it would turn into a over b. So, in question 1, I mentioned that the slope of a line in standard form is negative a over b. So, if we had the line ax plus by, we would find the slope by saying, well, it's going to be negative a over b. So we would get negative a over b as the slope, but we don't want negative a over b, we want positive a over b. So that means we're going to have to change one of the signs of either a or b, and we should change this sign right here, make it subtraction, because if we change the sign of this, it would no longer follow the convention for standard form, which states that the coefficient in front of x should be positive. So now that we have the proper coefficients, a and negative b, we need to find the constant. And again, to solve for that constant, we want to plug in a point that is on this line. In a perpendicular bisector, of course, it goes through the midpoint of the line segment. So we need to find the midpoint of the line segment and then plug it into this equation. So the midpoint, the average of 2a and 0 is a, and the average of 0 and 2b is just b. So we know that our perpendicular bisector runs through the point a, b. Plugging it in, we get a times a minus b times b, which equals a squared minus b squared. So we put that as our constant, a squared minus b squared, and that is our final answer. Ax minus by is equal to a squared minus b squared. So that was another perpendicular bisector problem. Again, remember, you need to find the opposite reciprocal slope and the midpoint in order to solve for the perpendicular bisector. Alright, let's move on to our 5th problem of the video. Alright, so this problem is kind of a y-intercept and x-intercept problem, but there is a little bit more going on here, so we do have to pay close attention. Consider line L, which contains the points negative 3, 8 and 6, negative 4. What is the length of the hypotenuse of the right triangle formed by L, the x-axis, and the y-axis? So in order to solve for the length of the hypotenuse, we would need to know the lengths of the legs of the right triangle. And in order to solve for the lengths of the legs, we need to know what is the x-intercept and what is the y-intercept, because the legs of this right triangle are going to be on the x-axis and on the y-axis. So in order to solve for those intercepts, let's solve for the equation of the line that runs through these 2 points. So first, let's solve for the slope. That would be change in y over change in x, which equals negative 4 minus 8 over 6 minus negative 3, which is equal to negative 12 over 9, which is equal to negative 4 over 3. Now that we have the slope of the line, let's solve for the y-intercept. So we would say that y is equal to negative 4/3 x plus b. And we can plug in one of our points. Let's just plug in 6, negative 4. So we say that negative 4 is equal to negative 4/3 times 6 plus b. Simplifying this, we get that negative 4 is equal to negative 8 plus b. And therefore b is equal to positive 4. So the equation of this line is y is equal to negative 4/3 x plus 4. Now already that tells us that the y-intercept is going to be 0, 4. And now let's solve for the x-intercept, which is when y is equal to 0. So we would say that 0 is equal to negative 4/3 x plus 4. Therefore, 4 is equal to 4/3 x, and of course, x equals 3. Given that, we know that the x-intercept of the line is 3, 0. So if we wanted to draw a picture of what this looked like, it would look like the following. So we would be in quadrant 1. This is the y-axis, this is the x-axis. We have a y-intercept of 0, 4, and an x-intercept of 3, 0. So the line would look something like that. And we have a right triangle here formed by line L, the x-axis, and the y-axis. Now we have the information we need to determine the lengths of the legs of the triangle, which gets us to the hypotenuse. So down here, we know that this point is 3, 0. And if this is 0, 0, then this length must be 3 units long. Similarly, we know this point is 0, 4. And if this is 0, 0, we know that this length is 4 units long. And given that we found 3 and 4, we recognize this as a 3, 4, 5 right triangle. So our hypotenuse length is equal to 5. So our final answer is 5. So they threw a fun little twist there with finding the hypotenuse of the right triangle formed, but in reality this was just an x-intercept and a y-intercept problem. So again, that's a reminder that intercepts are a super important part of this topic. Alright, let's move on to the last 4-pointer of the video. Line L has an x-intercept of 13, 0, and line M has an x-intercept of 11, 0. The slope of line L is 4/35 greater than the slope of line M. If the two lines intersect at a, 2, where a is less than 11, find a. Now, notice they say where a is less than 11. They probably wouldn't need to specify that unless there is more than one possible value for a. So be on the lookout for that. We're probably going to get some form of quadratic where we'll get 2 solutions for a. So we're going to have to report the one that is less than 11. We also know that both of these lines contain the point a, 2, and we also have another point on each of the lines. So given that we have 2 points, we can calculate the slope, which will be helpful because it tells us the information we need to relate the slopes to one another. We know that the slope of line L is 4/35 greater than the slope of line M. So if we solve for the slope of line L, that would be change in y over change in x. So that would be 2 minus 0 over a minus 13, or just 2 over a minus 13. Now it tells us this value is 4/35 greater than the slope of line M, meaning that we have to add 4/35 to the value of M. So let's solve for line M. We get that the change in y over the change in x is equal to 2 minus 0 over a minus 11, or just 2 over a minus 11. Again, relating these to one another, all we have to do is add 4/35 to this value. So we would say that 2 over a minus 13 is equal to 2 over a minus 11 plus 4 over 35. Now, let's subtract this term to this side, and we get that 2 over a minus 13 minus 2 over a minus 11 is equal to 4 over 35. Finding a common denominator, we would get that 2 times a minus 11 over a minus 13 times a minus 11 minus 2 times a minus 13 over a minus 11 times a minus 13 equals 4 over 35. Now, simplifying this, that numerator would be 2a minus 22 minus 2a minus 26. So the 2a's would cancel, and you're left with negative 22 minus negative 26, or in other words, negative 22 plus 26, which is equal to 4. So that numerator just simplifies to 4. So, and the denominator will stay a minus 13 times a minus 11. So we end up getting 4 over a minus 13 times a minus 11 is equal to 4 over 35. Now, if the numerators are equal, then the denominators must also be equal. So we can say that a minus 13 times a minus 11 is equal to 35. Now we need to put this into expanded form, so we get a squared minus 24a plus 143 is equal to 35. Subtract the 35, we get that a squared minus 24a plus 108 is equal to 0. We get our factor x out. We are looking for two numbers that multiply to 108 but add to negative 24. And those numbers would be negative 18 and negative 6. Therefore, the factored form of this quadratic would be a minus 6 times a minus 18 equals 0. And therefore, a would be equal to 6 or 18. So exactly like I had said in the beginning, we did end up with two answers. However, the problem says if a is less than 11, so only one of these answers is valid, and that would be a equals 6. So our final answer to this problem would be that a is equal to 6. Perfect. Now, if you're a visual learner, you like looking at graphs to see what exactly is happening, that helps you out. I would recommend going to Desmos and playing around with this problem. It is very neat. Make sure, connect the lines from 6, 2 and also 18, 2, see what that looks like. But for the purposes of solving this problem, algebra is all we really needed. And of course, if it helps you during the meet to have graph paper out and draw it like that, that's no problem. Go ahead and do that. But just keep in mind you won't have access to tools like Desmos to help you visualize it, so you might have to rely more heavily on your algebra skills. Alright, with that problem out of the way, let's move on to the 5 pointers of this video. Alright, here's our first 5-pointer. Determine k so that the line with the equation 3x minus 4y equals k is 6 over 5 units away from the point 2, 3. Now, in order to solve this problem, there is a super important formula that you need to know. How to calculate the distance from a point to a line when that line is in standard form. So, given our line is ax plus by equals c, and our point is x sub 1, comma, y sub 1, the equation for solving for the distance between the point and that line is as follows. The absolute value of a times x sub 1 plus b times y sub 1 minus c all over the square root of a squared plus b squared. Again, this equation is to find the distance between a point and a line when that line is in standard form. Knowing this equation, we can apply it to this problem. So we know the point, we know the distance, the only thing that we don't know is the constant k. So let's go ahead and plug all of the values that we know into this formula, and hopefully we'll be able to get something where we can solve for k. So 3x minus 4y equals k, and the point is 2, 3. So the numerator would be 3 times 2 minus 4 times 3 minus k all over the square root of 3 squared plus negative 4 squared. And that's the distance, and it equals 6 over 5 units. Now, notice, this denominator, 3 squared plus negative 4 squared, and take the square root of that, that ends up being 9 plus 16, which is 25. And the square root of 25 is 5. So the denominators end up being the same. And if the denominators are the same, then the numerators must also be the same. So we can say that this numerator is equal to 6. So we can say that, well, the absolute value of, and then we have 6 minus 12, so 6 minus 12 is negative 6. The absolute value of negative 6 minus k is equal to 6. So therefore, negative 6 minus k is equal to 6, or negative 6 minus k is equal to negative 6. Add 6 to both sides. Negative k is equal to 12, or negative k is equal to 0. And therefore, k is equal to 12, or k is equal to 0. So the final answer to this problem would be 0 or 12.
Just a quick editor's note, I want to make it absolutely clear that the answer should be 0 or negative 12, not 0, or 12. As you can see in the video, I made a slight sign error and I didn't catch that mistake at the time of recording. So I just, again, want to make it absolutely clear that the correct answer is 0 or -12. All right, let's hop back into the video.
Now the big takeaway from that problem is how to find the distance from a point to a line in standard form. So again, that formula is where ax plus by equals c, that's the line, and x sub 1 comma y sub 1, that's the point. So the equation is the absolute value of a times x sub 1 plus b times y sub 1 minus c, that minus c is important, over the square root of a squared plus b squared. So that formula is important. It will probably show up at the meet, so it's a good one to know. Alright, let's move on to our next 5-pointer. Alright, so in this problem they give us 3 coordinates, which are the vertices of a triangle, and it tells us to find the point, which is the intersection of the median to side AB and the perpendicular bisector of side BC. Now, we've seen the perpendicular bisector before in this video, but we have not seen median. So the median is defined as the line segment that connects a vertex to the midpoint of the opposite side. Okay, so for example, if our triangle looked like this, the median to this side would go through the midpoint and the vertex. So this right here would be the median. So now that we have both median and perpendicular bisector defined, let's go ahead and solve this problem. So the median to side AB would have to go through vertex C, and it would also have to go through the midpoint of AB. So it has to go through C, which is 4 comma -2, and it also has to go through the midpoint of AB. And to solve for the midpoint is easy enough. It's just the average of the x values and the average of the y values. So the average of x, 0 and 2, that's 1. And then we have 0 and 6, which is 3. So the midpoint is 1 comma 3. And it also goes through 4 and -2. So we should be able to create an equation from those 2 points. So the slope would be the change in y over the change in x, which would be 5 over -3. Or we could write -5/3. So now that we know the slope of this line is -5 over 3, we can say that y is equal to -5 over 3x plus b. And let's solve for b. Let's plug in the midpoint. Why not? 1 comma 3. So we would say that 3 is equal to -5 over 3 times 1, which would just be -5 over 3. And then add b. So we would move the 5 over 3 to the other side, and therefore b is equal to 14 over 3. So this line then becomes y equals -5 over 3x plus 14 over 3. So that's the median to side AB. Now let's find the perpendicular bisector of side BC. And remember, in a perpendicular bisector, you need the opposite reciprocal slope and the midpoint. So let's start with the slope. BC, the change in y would be -2 minus 6. The change in x would be 4 minus 2. So we're left with -8 over 2, which is equal to -4. Opposite reciprocal would be 1/4. So we know that the equation looks something like y equals 1 over 4x plus b. Now we can solve for b, but before we do that, we need to find the midpoint that this perpendicular bisector runs through. So we have the points b and c. The average of 2 and 4 is 3, so the midpoint's going to have an x-coordinate of 3, and the average of 6 and -2 is 2. So the perpendicular bisector is going to run through the point 3, 2. Knowing this, we can plug it into this equation to solve for b. 2 is equal to 1/4 times 3, so 1/4 times 3 is just 3/4, plus b. And then if we subtract 3/4 on both sides, we find that this b is equal to 5 over 4. So the equation would be y is equal to 1 over 4x plus 5 over 4. So that's the perpendicular bisector of side BC. And now we have two equations, both in terms of y. So let's set the right sides equal to each other to solve for x. So we say that -5 over 3x plus 14 over 3 is equal to 1 over 4x plus 5 over 4. Now, it would be nicer if we had a common denominator, and so that common denominator would be 12. So we can say that negative 20 over 12x plus 56 over 12 is equal to 3 over 12x plus 15 over 12. Now, if every term is divided by 12, well, let's just multiply every term by 12 to get rid of that denominator. So we're left with, if we multiply everything by 12, negative 20x plus 56 is equal to 3x plus 15. Now, let's add 20x to this side, subtract 15 on this side. We get 41 is equal to 23x, and therefore x is equal to 41 over 23. It's a pretty nasty fraction, but that is actually the correct answer. So given that we know that x is equal to 41 over 23, let's solve for y. Now, it doesn't really matter what equation we use, both are probably going to be equally messy, so let's just plug it into y equals 1 over 4x plus 5 over 4. So over here, we have limited room left. We would say y is equal to 1/4 of 41 over 23 plus 5 over 4. So that would equal 41 over 92. And then we would want a common denominator with 5 over 4. So we would multiply both the top and the bottom by 23. This ends up being 115 over 92. And then add them together. 41 plus 115 is equal to 156. So we would say this equals 156 over 92. And both the top and the bottom are actually divisible by 4. So when you divide both of those by 4, you end up getting 39 over 23. So the x-coordinate is 41 over 23. The y-coordinate is 39 over 23. So our final answer, we have room up here, so let's write it. The answer would be 41 over 23, comma, 39 over 23. Now, the key takeaway from that problem is the median. A median is defined as going through one of the vertices of the triangle and the midpoint of the opposite side. We also had to deal with a perpendicular bisector, but we've done that before, so I would say the bigger takeaway is making sure you know what a median is and how to solve for it. Alright, with this problem out of the way, let's jump into the final problem of this video. Alright, here's the last problem of the video. 10 comma minus 2 and 6 comma minus 4 are the vertices of the base of an isosceles triangle. The third vertex of the triangle is 10 units from the base of the triangle and is in the first quadrant. Find the coordinates of the third vertex. Now, given that we see 10 units from the base and that we're solving for a point, I'm immediately thinking, well, let's use the formula to solve the distance from a point to a line. And while that approach is certainly valid, there is an easier way to solve this problem. In order to do it, we're going to have to draw what this problem looks like. So let's graph roughly 10, negative 2 and 6 comma negative 4. 10, negative 2 might be something over here, and 6 comma negative 4 might be something that looks like this. So this is the base of our isosceles triangle. Now what's important to know is that in an isosceles triangle, the vertex that is opposite the base will be on the same line as the perpendicular bisector of the base, right? Because if we're looking at an isosceles triangle, it looks something like this. What we're able to do is drop this altitude down, and when we drop this altitude down, we notice that not only is this the midpoint of the base, but it actually forms right angles. So with this knowledge of isosceles triangles, we know that the vertex lies on the same line as the perpendicular bisector of the opposite side. We can use that knowledge to our advantage in this problem. Alright, so our vertex is going to lie somewhere on the perpendicular bisector. So if we were to draw the perpendicular bisector, it would look something like this, and it could lie anywhere on this line. Now it tells us that it's 10 units from the base of the triangle and is in the first quadrant. So this part of the line would not be valid. We're only looking for things up here. Additionally, we know that this distance is going to be 10 units. So it'll be something like that. I'm not sure if that's exactly 10 units based on the scale of this graph, but it doesn't much matter. The point is, this right here, we know is 10 units long. So now the question is, how do we find where this coordinate point is? The answer, we draw a right triangle using our knowledge of what the slope of this base is. Okay? So first, let's draw that right triangle. So we drop this down and this down. So right here, this is a right triangle. So 10 is our hypotenuse. So I'm going to draw a bigger version over here. 10 is our hypotenuse, and we're solving for the change in y and the change in x. Now, right now, this information isn't very helpful to us because we have two unknowns. But if we only had one unknown, then we would be able to use the Pythagorean theorem in order to solve for that unknown. And so now we have to think about slope in order to get this to a single unknown. First, let's solve for the slope of the base. So these 2 points make up the base, so it would be -4 minus -2 over 6 minus 10, which is equal to -2 over -4, which is equal to +1/2. So if the slope of this base is +1/2, the slope of the perpendicular bisector is going to be -2. So we know that slope represents rise over run. So -2 means that for every unit we go to the left, we go 2 units up. So in this case, if this is our starting point, we could say that we move x units to the left. And if we move x units to the left, then we would move 2x units up based on the slope of this hypotenuse. So instead of writing y here, we could call this 2x. Now that we know that, we can use the Pythagorean theorem and solve for x. Now it's important to note that this x, it won't be the x value of the point, it will be the change in x. Just keep that in mind. So we say that 2x squared plus x squared is equal to 10 squared. Make sure to square both the 2 and the x. So 4x squared plus x squared is equal to 100. Therefore, 5x squared equals 100. X squared is equal to 20. And therefore, x is equal to the square root of 20, or 2 times the square root of 5. So we know that this right here is 2 times the square root of 5. This right here is 4 times the square root of 5. So now we know both the change in x and the change in y, but what are we changing from? We are changing from this midpoint. So we also need to solve for that midpoint, and the midpoint, just average the x values, which is 8, average the y values, which is -3. So from that point, this is our change. We go 2 root 5 units to the left and 4 root 5 units up. So our vertex in quadrant 1 would end up being the following. So the x, we are subtracting 2 root 5, so it's 8 minus 2 root 5. For the y, we end up adding 4 root 5. So it ends up being -3 plus 4 root 5. And that is our final answer. Now you could have gotten the same answer using the formula that we covered before, which is the distance from a point to a line. However, this solution, in my opinion, is actually more elegant, and it definitely is easier. Thinking about it in terms of slope, so that we draw a right triangle where we can solve for the change in x and the change in y, I think that's a very interesting way to approach this problem, but it also is very efficient. The takeaway there is that even if you know formulas and you're ready to use those formulas on a problem, think about it for a moment and say, well, is that really the best way to solve this problem? So the formulas that we learn are just tools that best equip you for this meet. However, you have tools already. So if the tools that I'm giving you now aren't the best tools to solve the problem, then go to the tools that you already had. And in this case, you already knew slope, you already knew the Pythagorean theorem, and you would have been able to use that knowledge in order to solve this problem, as opposed to the formula that I just gave you 2 problems ago. All right, With that problem out of the way, that concludes this video on linear coordinate geometry. This was our video on 9 problems from Meet number 4, topic number 3, linear coordinate geometry.
Thank you for watching.
I'm Sebastian.
And I'm Iris.
And we're the MAML Manual.